Hey everyone, and welcome back to this class, Data Science, Deep Learning in Python, Part 2. In this lecture, we are going to implement random search in code. This is going to be very similar to the grid search code, except that now we are not searching through a grid, but rather selecting the next set of hyperparameters randomly. If you don't want to try to code this yourself, although I highly recommend you do, the relevant file is randomsearch.py in the course repo. It shouldn't be too hard at this point since you already have a template for what to do given the last lecture. So the imports are all the same as before. The meat of this file is really the random search function. The first part is the same as before. We get the data, split it into train and test, which is really more like a validation set. Next, we choose a set of starting hyperparameters. You could of course make this random as well, but I've chosen to start at this exact setting. This is 2 hidden layers, that's n hidden, each of size 20, that's m. For the learning rate and L2 penalty, I'm actually going to search through the log of these hyperparameters. There are two reasons for this. The first reason is that the learning rate and L2 penalty have to be positive, so if I work in the log space and then later exponentiate these values, I can ensure that they'll always be positive. The second reason I want to do this is because this is the scale at which we usually test hyperparameters such as learning rate and regularization. Typically, if you've tried a learning rate of 0.1, you won't try 0.099 or 0.098. You would try 0.1, 0.01, 0.001, and so on. This is a log scale. We also have the max tries parameter. This is the number of different hyperparameter settings we'll try. Next, we go to the main loop. The first part is the same as before. We create a model using the current hidden layer size. We fit the model using the current learning rate and L2 penalty. We get the validation accuracy and the train accuracy, and we print them along with the current hyperparameter settings. If the validation accuracy is better than the best so far, we set these hyperparameters to be the current best. The next part is different. This is where we choose the next hyperparameter setting. You can think of each hyperparameter as a dimension, and so the complete set of hyperparameters is like a vector. So we are essentially searching within a hypersphere around this vector. In simple terms, we are going to go plus or minus a certain amount in each direction, or in other words, for each parameter. So for example, the new n hidden will be the best n hidden plus -1, 0, or 1. N hidden, of course, can't be less than 1, so we take the max of that with 1. We do the same thing for m, the number of hidden units, but we search in multiples of 10. Finally, when we're done with the loop, we print out the best validation accuracy along with the best hyperparameter setting. Let's run this and see what we get.